Okay, we've seen this already. We've got our x-axis, we've got our y-axis, and we've got a line and the space, two dots on the line, and you got your rise over your run, and that's your slope. Okay, the letter representing slope is always m. So the m value is rise over run, and you have to get the numbers to do that to actually calculate the rise and the run. So that's what we're going to do next. We've got an actual example. Don't know how many times I'm going to be able to do that in one lesson, but here we go. You've got, here we go, x and y. You've got x is going up by ones, you've got y is going up by ones, and you've got 2 points on the line. So my first point here looks like it starts around 3 and 2. So this dot right here is 3 and 2. That means I went across 3 and up 2 to get to it. So that's why 3 and 2, that's always xy. Okay, so it's always an xy, and there's 3, 2. And the next dot is at 7, and it looks like 7, 5. Cross 7, up 5. So there's our 2 dots. And what we need to do is figure out how much its rise is. So the rise from 2 up to 5, from 2 to 5 is a rise of 3. So my rise is 3. And my run from 2 to 7, from 3 to 7 is a rise of 4. So my slope is a rise of 3, a run of 4, and that's our slope. Another way of calculating it, this is actually the preferred way to calculate it, is to use a very specific equation. So I'm going to do that next. The equation is y2 minus y1 over x2 minus x1. So y2 over y1 over x2 and x1. And you need to sub in the points. Now, in order to sub in the points, you need point 1, which is x and y, and then point 2, which is x2 and y2. So in order to do that, it doesn't really matter what point you decide. So if you want the first point to be point 1, which makes sense, then let's do it that way. And the second point is going to... Okay, so when we've selected the points 1 and 2, we need to sub it into the equation y2 minus y1 over x2 and x1. So I'm just going to look at the y's to start, and I know y2 is a 5 minus, and I know y1 is a 2 over x2 is a 7 and x1 was a 3. So 5 minus 2 is 3. 7 minus 3 is 4. And I get a 3/4, which is the exact same thing as when I visually looked at it, rise over run. It was also 3 over 4. Rise of 3, run of 4, and that gives us a slope. So a couple different ways of calculating slope. You can do it versus using a table of values. You could do it in a graph. If the rate of change is the same in a table of values, that's the slope because it's a straight line. And in a graph, if it's a line, a straight line, then rise over run works, and that'll give you slope. The equation, the preferred equation, y2 minus y1 over x2 minus x1. Now let's get into some very specific examples of determining a slope just having 2 points. So no visual, no graph, just determine the slope of the that's passing through the following 2 points. So I'll show you how to do those ones and a couple word problems as well. Okay, so the very first question for determining the slope of a line passing through the following points, we've got points at 3, 6 and 7, 7. Remember, it is x, y, and we're going to call this point 1 and point 2, although it does not matter. Okay, so the equation, the preferred one, is y2 minus y1 over x2 minus x1. So there's your preferred equation, y2 minus y1. Now y2 is over here. It's a 7. So I'm going to write that down. 7 minus y1 is a 6. Okay, x2 is over here. It's a 7 minus over here x1 is a 3. So 7 minus 6 is equal to 1 over 7 minus 3 is 4. So my slope in this case is 1/4, or a rise of 1 and a run of 4. We got another example here. We've got 8, 4 and negative 1, 16. So 8, 4 and negative 1, 16. Again, does not matter which one I name as point 1. I'm just going to arbitrarily do that. Point 1 and point 2. So I got point 1, point 2, and I need my equation. So y2 minus y1 over x2 minus x1. Now, y2, I'm looking at point 2, and the y value is the second value, so it is a 16. 16 minus y1 is a 4. Now we have x2, which is a negative 1, minus x1 is an 8. So now it's straight subtraction. 16 minus 4 is 12. 12 over negative 1 minus 8 is negative 9. So 12 over negative 9, and you could put that into lowest terms, but that's the slope. Okay, so you're going to have a rise of 12 and a run of 9, but it's negative, so it's going down. Okay, the last 2 questions are word problems. The first one, Andrea and Dana cycled 56 kilometers in 2 hours and 112 kilometers in 4 hours. At what rate were they cycling? The rate is otherwise known as the slope. And in order to calculate the slope, we need to decide what's my x value and what's my y value. So what's my independent variable that's changing predictably, and then what's my dependent variable that I'm measuring. So when you go cycling, you're on your bike or you're competing in any kind of race, you have time and distance. Now, which one is changing predictably? Time. And which one are you measuring? It's your distance. So in this case, you've got time on the x, you got distance on the y, and you're going to calculate a slope using the 2 points. So let's do that now. Andrea and Dana cycled 56 kilometers in 2 hours. So when you're doing that, 56 kilometers in 2 hours, the x-axis is independent, it's changing predictably, and time is changing predictably, so that's the 2 hours. And 56 kilometers is the distance they traveled in 2 hours. And the next one is 4 hours and 112 kilometers. So we've got 6 and 56, or sorry, 2 and 56, and then we have 4 and 112. Now, in order to calculate this, y2 minus y1 over x2 minus x1. So there's my equation, and I just need to decide which point's 1 and which one's point 2. It does not matter which is which. I'm just going to go, the first one is 1, second one is 2, because that just makes sense. And I have y2 is 112. So I'm going to write that down, 112 minus 56 over 4 minus 2. That is equal to 112 minus 56. We've got, I think that looks like 56. And 4 minus 2 is 2. So 56 over 2, again, that's the rise over run. That's your rate of change. That's how fast you're traveling. 56 kilometers every 2 hours. That's not typical. You want to put it in lowest terms. That makes a little more sense. So divide 56 by 2, put it in lowest terms, and you get a speed per hour. So 56 goes in 28 times. So 28 kilometers per hour. That's how fast you're traveling. All right, the last question. The depth of the water in a tank was 5 feet. At noon, Haley started draining water out of the tank at a rate as shown by the graph below. Based on the rate shown by the graph, at what time will the depth of the water in the tank be 2 feet? So, taking a look at this graph, we have it's starting at noon and about 5 feet, not exactly 5 feet. And at 1 p.m., it's down to 4.5 feet. So it's halfway between 5 and 4, which is 4.5 feet. So it's dropping half of a foot every hour. Now, I'm taking a look now at the 5 p.m. time, and the depth is 2.5 feet at 5 p.m. If it's 2.5 feet at 5 p.m., when's it going to be 2 feet? Well, it's dropping half a foot every hour, so it should be at 2 feet at 6 p.m. So it dropped half a foot every hour. 5 p.m. it's 2.5. 6 p.m. it should be 2 feet based on the slope that is taking place here, the rise over run, negative a half foot every hour. And anytime you have a line, any 2 points on the line will follow that same slope. Doesn't matter what, you should always, if it's linear, follow that. The second set of questions is page 156, numbers 3 to 5. Question 7, only A, C, and E. 12 and 14.